multiply and divide decimals by powers of 10. What are powers of 10, first of all? Say. Sure. Or an example, or whatever you got. No, powers of 10. Not powers of 4. Powers of 10. 10 to the what? 10 to the second power. What is 10 to the second power? No? 10 to the second power. Desriano. Good, right. So 10 to the second power means I'm going to take how many 10s and multiply them? 2. Okay? Right, so 10 to the second power is 10 times 10, and we say that equals 100. What's 10 to the first? There's just one 10, therefore it's just 10. 10 to the 0 power, not 0, just 1. Now, you can look at these a number of ways. If I have 10 to the second power, that means I have a 1 with how many zeros? 2. 10 to the first means I have a 1 with how many zeros? 1. 10 to the 0 means I have a 1 with how many zeros? 0. 10 to the third means I have a 1 with how many zeros? Okay? So powers of 10. All right? Give you a second to get that down. Well, just so you have an understanding of it, it sure is a better choice to actively take notes, participate, write the stuff down, than it is to just sit there and watch. As long as you understand it doesn't stop with 10 to the third power. Go on and on. Casimir. Ten to the third means I have a 1 with how many zeros? 3. That's how you can read it pretty quickly. Zay?
10 to the power, like 10 to the third power, can the 3 go higher than 10?
The 3 go higher than 10. Yeah. That means you'd have a 1 with how many zeros? 11. Possible. Okay. Now let's take a look at some simple, let's say, what do you know if we just take 3 times 10, what is it that we come up with as a product? Right. 30. If we say 3 times 100, what is it that we say that becomes? Mariah? 300. If, okay, 3 times 1,000 must be then, Alexis? Okay, 3,000. I want you to look at this carefully, because what we just did, whether you realize it or not, is we just multiplied by powers of 10. But there's an even shorter cut to all this. For today, they're not going to tell you 3 times 10. They're going to say 3 times 10 to the first power. They're not going to say 3 times 100. They're going to say 3 times 10 to the second, and then 3 times 10 to the third. Okay? Now I want you to focus on where the decimal is. In the number 3, in all cases, our decimal is there. Now, how did we get from this to this? We had it here, and we moved it how many places? 1 place to the right. We had it here, and we moved it 2 places to the right. We had it here, and we moved it 3 to the right. Now, for the most part, you know that when you multiply, your number usually gets bigger. And in the cases that we had, in all of them, I went from 3 to 30. Did it get bigger? 3 to 300, 3 to 3,000, definitely got bigger. So when you multiply, okay, multiply by positive powers of 10, move decimal to the right, as many places as the power says. Well, it doesn't really say anything, but you know what I mean. 3,000 divided by 10 to the third power. So if we, when we multiplied by powers of 10, we moved to the right as many places as the power told us. When we divide, if it's multiplication's opposite, the opposite of right, Tequila must be left. So first of all, we need to locate where the decimal is in 3,000, which is there. And then to move it 3 places, 1, 2, 3, puts us at what number is that now? 3. Do you need all these extra zeros? No. And we go and we say, okay, well, 300 divided by 10 to the second, we would say, well, 2 places equals 3. What happens, though, if we get a situation like this, where it says, okay, you've got 3, and we're going to divide by 10 to the second power. I need to move it how many places, Carlos? I need to move it how many places? I need to move it how many places? 2 places. So, 1, 2 means I have to put what there? A 0. There you go. Okay. So what you were trying to say, I think, was this. Okay. So in some cases, you'll need to add a 0. Just like if we had a situation like this, Maya, we said, let's do 3.4 times 10 to the 4th. So I know where my decimal is, and I'm going to have to move it how many places? 1, 2, 3, 4, and I need to add zeros in these open spots. Your new answer becomes 34,000. Okay. Yes. This is a 10th power. 10 to the 4th power is powers of 10. 10 is our base number. We've done stuff like this that's been very similar, yes. All right, let's try a couple of multiplication. Try that one. Try those two. So I'm going to go 3 places to the right as I'm multiplying. So my new number is 4,081.6. 3. How have you got it? Over here, I'm dividing, which means I'll go to the left, to the second. So 1, 2. So I get 0.51045. How many of you got that? Oh, yeah. Sierra, do you have to put the 0? You don't necessarily have to. Now there is a catch. Because, there always is. If you remember way back when I wrote that long passage down here in black, that I put positive in quotation marks. Because sometimes we'll have negatives. Now there are only 2 directions I can move my decimal. Left or right. Correct. If this were just a regular positive 10 to the first power, I would move my decimal what direction and how many places? Right 1 place. However, would you ever tell me that -1 is the same as 1? So why then would I move the same direction? In fact, -1 is the opposite of +1. So again, I'm not going to go to the right one. I'm going to go to the left one. So now I have 5,700. So if it's a negative power, I treat it just like it were the opposite operation. Okay, Carlos? What we are doing is taking a major shortcut. Because what is 10 to the negative first power? It really is, it's this. So if we were to multiply 57,000 times 0.1, we just did this. I would multiply 57,000 times 1, it would be 57,000, but I'd have to move that decimal 1 place. We just did that. So that's why 10 to the negative first power, we're moving that to the left. Because the negatives are essentially the decimal parts. So let's take a look at a couple of those examples. (17 times 10 to the negative third). Try those two. All right. Now, ordinarily, we would look at this problem and say 17, we're going to multiply, we're moving to the right. However, once I get a glimpse of my power and see that it's negative, I'm not moving to the right anymore. I'm going to move to the left. How many places? So I locate my decimal. If it's not visible, that's where it is. And we go 1, 2, 3, and we should get 0.017. You need that 0. The other one you don't necessarily need. Okay? But you need the one that I put the arrow by. All right, so the next one. Question? Yeah? You need the decimal in front. Okay? It's all about the decimal. 364 divided by 10 to the negative 2 power. Well, ordinarily, if I was dividing, Casimir, I'd move to the left. But because it's a negative power, I will move to the right. How many places? 1, 2. So I have a 364 with 2 zeros after it. Where do I put my comma? Pardon me? You do the opposite of what you would normally do when it's a negative power. The number of places is the same, you just move the opposite direction. Casimir. No, I move my decimal 2 places to the right instead of 2 places to the left, which I normally would do when I divide. I moved them to the right because it's a negative power. No. When you divide, okay, here. Multiply by a positive power, move decimal to the right. Multiply by a negative power, move decimal to the left. Okay? That takes care of both of your multiplication scenarios. Multiply by a positive power, you move the decimal to the right. Multiply by a negative power, move the decimal to the left. Divide by a positive power, decimal to the left. Divide by a negative power, move decimal to the right. Your assignment worksheet 7-3, numbers 3 through 14. The redo page 170, numbers 5 through 8.